Morning, everybody. I want to just say hello to you and God bless you. And I've been praying for you like usual. And I can't wait until we get a chance to see each other face to face again. I know that won't necessarily be for an instruction time, but I'm hoping to at least uh, see you in some way, shape, or form, whether it be for whenever graduation is rescheduled to, or whether it be at book drop off at the end of the year or sometime. I'm just really hoping to see you again. And in the meantime, we'll just keep on encouraging each other and hopefully being able to find other ways to be able to connect with each other. Okay. All right. So let's take a look here. We're going to look at graphing inequalities today. Notice it's inequalities, not equations. So we have our inequality marks on there. So we know we've been talking about graphing equations, and so we use a lot of the same things that we used in graphing equations in order to graph an inequality. Okay, you've actually graphed some inequalities before. You've done the ones that have just one variable and you've shaded in part of a number line. Well, it's kind of like that, except for that we're going to be graphing lines first in order to make that happen. So I have some examples to show you in a little bit as far as the graphing. But before that, we have to get the idea that there are millions and millions. There's actually an infinite number of solutions for each one of these inequalities. Well, what is a solution to an inequality? A solution to an inequality is an x value and a y value that when you plug it in to the inequality is going to show itself to be true. Now, that being said, there are millions and millions, there's an infinite number of solutions, but there are an infinite number of ordered pairs that are also not solutions. So what I have here is I have a list of 4 ordered pairs. Each one has an x value and a y value. X and Y, X and Y, X and Y. And we're going to plug them into these inequalities and see which ones make it true. Okay, and that's your first thing, is you have to know that you're really, when you're giving these solutions, when you're finding these inequality graphs, you're actually showing a list of the solutions, okay, and where the solutions live. So let's take a look at this first one. X plus y is greater than 2. And we want to check all these numbers for that. So if I'm trying to check to see if x plus y is greater than 2, and I want to check this one, I want to check out A, let's color code them. Let's make A in black and B in red and C in green and D in blue. Okay, so if I want to check to see if 0 plus 0 is greater than 2, and I find out, no, that's not true. So that means that the ordered pair 0, 0 is not a solution. Okay, let's check to see if negative 2 plus negative 1 is greater than 2. Negative 3 greater than 2. No, that's not true either. That's not a solution. Let's see if 5 plus 3 is greater than 2. Hopefully you're getting the idea here. 8 is greater than 2, so yay. Okay, so C is a solution here. Now, since I said that there are an infinite number of solutions, you always have to check all of these. Now, this is kind of a long way of doing things, because you're going to get tired over your life just checking number after number after number to see if it fits in here. So that's going to be our point to making the graphs that we'll see shortly. But in the meantime, let's just do this the long way to start with. So I've checked this equation. Now I want to check this other equation. I want to check, let's check out y is less than or equal to negative 2x minus 1. Our x value comes first, then our y value. Okay, so 0 less than or equal to -2 times 0 minus 1. Okay, 0 is less than or equal to -2 times 0 is 0, minus 1 is -1, so that one's a no. Let's check and see about -2, -1. Now keep in mind this is your y value, so you're seeing -2 less than or equal to -2 times x. I messed that up. I'm looking for y. Y is -1. So we do have to be careful. Y is -1. -1 is less than or equal to -2 times -2 minus 1. We want to check and see if that's right. -1 less than or equal to 4 minus 1. -1 less than or equal to 3. And that one's correct, so B is an answer here. Let's check out C. X, Y, X, Y. So I need to check out to see if 3 is less than or equal to -2 times 5 minus 1. 3 is less than or equal to -10 minus 1. 3 is less than or equal to -11. Nope, that one does not work. And then finally, let's check out D. D, X, Y, X, Y. Y is 5 less than or equal to -2 times -2 minus 1. 5 less than or equal to 4 minus 1. 5 less than or equal to 3. No, that's not. So just B is our answer for this one. Then we can look at the next one. We can look at here. We need to look and check and find the answers for x greater than or equal to -5y. Now this one, okay, we're going to try 0, 0. 0 greater than or equal to -5 times 0. 0 greater than or equal to 0. Well, yeah, it's not greater than, but it is equal to, so this one actually works. So A is an answer that works here. B. Let's check out B. X, Y. -2 greater than or equal to -5 times -1. -2 greater than or equal to 5. Nope. So B doesn't work here. How about C? Not -2, 5. We're on the next one. We're on C, where x is 5 and y is 3. So 5, checking to see if 5 is greater than or equal to -5 times 3. 5 is greater than or equal to -15. Sure it is. So that tells us that C is also working here. And then D, -2 greater than or equal to -5 times 5. -2 is greater than or equal to -25. Sure it is. So D is also a solution here. So what you can see is sometimes you can, if you're given a list, sometimes you get a solution, sometimes you get 2 solutions, sometimes you get 3 solutions, and on and on and on with that. Okay, so now we know the long way of figuring out which is a solution, but that's not acceptable for being able to do a whole bunch of different problems all at once. So what we need to do is we need to be able to make a graph, okay? We need to be able to make a graph of inequalities so that then what we can do is we can find out where the solutions live for these particular graphs. Now, in a little while, we're going to be actually making these lines to go with it, but I want to make a point first before we get to that, is that when you're going to be graphing an inequality, the first thing that you look for is the border. Okay? Notice that the border looks very different from this one and this one. On here, the border is a solid line, and here the border is a dashed line. It's just like when you were graphing inequalities as an ordered pair, when you're graphing inequalities on a number line, where you have an open dot or a closed dot. Because here the numbers that are equal to are also solutions, and here the numbers that are equal to are not solutions, but you do have a dividing line. Okay, so we've got our dividing line here. So what we need to do then is we need to figure out where the other solutions are. The solutions will either be on this side of the dividing line or this side of the dividing line. Okay, all of those right answers, all those infinite number of answers. Yes, just in case you missed it, there are an infinite number of solutions to this. There are an infinite number of solutions to this. So the way we find where the shading is, and yes, I know that some of you can see on the side where the shading is, the way we find it is we take a test point and we pick that test point. 0, 0 is a great test point because 0, 0 is very easy to work with because you're picking two of the same number, and a lot of times the zeros will just completely disappear, so it makes it easy. You pick a test point and you figure out if the test point that was my dog who decided it was infinitely important and exciting that my daughter came out of her room so that she could get ready for work. Anyway, on we go. So what we're looking for is we're looking for the portion of this graph that has all the solutions in it. And if you pick a test point such as 0, 0, if you find out that it makes this true, then all of the solutions are on the same side of the border with that solution. If you find out that it's false, your test point, that means that all of the solutions are where that point is not located. They would be on the other side of the dividing line. So what we can do is we can check out our test points for this. Okay, so for example, if I want to test the ordered pair 0, 0, and we know where 0, 0 lives, all I'm doing is I'm just checking one point. I don't have to check a whole bunch of them, and I plug in 0 greater than or equal to -2 times 0 plus 3. What I find is I have this. Now we find out that 0 is greater than 3. Well, that's false. Okay, so since it's false, it means that the answers, since one answer isn't over here, none of the answers are over here. All the answers are on the right-hand side rather than the left-hand side. So what you do is you take your pencil or whatever you have and you shade in the side of the graph where the answers live. Now I accidentally went over that just a little bit, so I will take my eraser and I will erase, if it'll let me. I'm going to erase the places that I shouldn't have shaded in. Okay, now your shading will not necessarily be perfect, but we know what you mean here. So the answers over here are where all of the right answers are. So any point in the shaded region would be correct. So for example, 3, 2 would be a true point. 4, 4 would be a true point. 5, 5 would be a true point. All of the millions of ordered pairs over here would make this inequality true, as well as anything that's along the border because it says we're equal to. This other one, if we want to test the ordered pair 0, 0, where x is 0 and y is 0. You have 0 plus 0 is less than 3. And that's actually true. 0 is less than 3. So what you do in that case is you go to where 0, 0 is, and you understand that all of the solutions are on the same side of the border where 0, 0 lives. So all of the solutions are over here. I'm getting this all shaded in as best I can. You take a pencil and you shade in. Okay? And so all the solutions are over here. So any of the ordered pairs that are over here would give you a solution. Okay, so you're checking. You pick a test point. 0, 0 is usually the most convenient test point. If you get a true answer, you shade where the 0, 0 is, and if it's a false answer, you shade on the other side. So this one was true, so I shaded where 0, 0 lives. This one is false, so I shaded where it doesn't live. So we need to be able to graph, we need to be able to do this graph completely and totally on your own. So from beginning to end, where we make the border as well. So I've chosen 4 examples to help you along with your work. And since tomorrow is no video and a work day so that you can work on the assignment, please do yourself a favor, set yourself up in a good place for your Algebra 1 class next year by doing a fantastic job of these graphs. Okay? So what you need to do first is you need to pretend that this says x plus y equals 4, or x plus y equals negative 4. And then you need to make a graph. Now, you don't have to pick a whole bunch of ordered pairs for this. Remember, we have the method where you can pick the x and y intercept and use that. Notice there's no or equal to here, so when we make this border line, we're going to make it as a dashed line rather than a solid line. So I just want to find my x and y intercepts. This will be our easiest way to get our graph line to start. So when x is 0, y equals negative 4. So I will start by putting my point at the ordered pair 0, negative 4. 1, 2, 3, 4. And then I need to find my other one, and this is going to be your easiest way. Is just find your x and y intercept. Y is 0, so x plus 0 equals negative 4. So in this case, the x-intercept is also negative 4. So over here at negative 4. Now remember, these are not solutions. This is our borderline. Okay, so for your borderline, okay, now this tool doesn't have a dashed feature, and it's too hard to draw a straight line without, so I'm going to have to use this. What you can do is you can take your straight edge, take your ruler, go down through, and I have missed. Okay, so you're going to be able to do a better job because you're actually set up a little better than me for this. Okay, so you're going to make your straight line that goes through your points. There would be your line. And what you need to do is you need to have some white out if you're using a pen, which you shouldn't be, but if you were using a pen, or you take your eraser and you make this line dashed instead of solid. You need to have a bigger eraser for that. There we go. We'll make a dashed line here instead of a solid line. So I go through and I dash my line so that this shows that the line is not actually the solution, it's just the border of the solution. So then the next thing you need to do is you need to go back to thinking of it as being an inequality. So since we're looking at it as being an inequality, what you need to do is you need to test a point. I notice that 0, 0 is not on the line. If it were on the line, you'd have to pick a different test point, but I'm going to test the ordered pair 0, 0, And when I put that in there, x is 0, y is 0, greater than -4. I get that is true. 0 is greater than -4. So you will take your side of your pencil, okay? You start where 0, 0 is, and all of the solutions to this are over here on this side of your borderline, okay? You're going to be able to do it even a lot nicer than this. I'm specifically doing it this way because this is what you will do. This will be your process. So all of the solutions are over here, okay? So there is your graph of x plus y is greater than -4. 0 plus 0 is greater than -4, so that's your solution. Okay, now I'm going to go through and I'm going to show you several others, so please stick with me because each one has its own special thing that you might find difficult. I know that some of you were still having trouble doing graphs of lines, so this is helping you also for those of you that have trouble doing graphs of lines. So we want to take a look at this one. Now this one's interesting. Why? And remember, we always start when we're going to graph, we're going to start with pretending it's an equals and figure out what that graph would look like. Decide whether it's going to be solid or dashed, and then find where the shading is. So y equals -4. Let's think about what that graph would look like. Now we could try to think about intercepts. So when x is 0, y equals -4, because y always equals -4. So we'll go down here, 0, -4, 1, 2, 3, 4. But the thing is that y equals -4. Y always equals -4. So we can't do what about when y equals 0, because y is just plain never going to equal 0. It's always going to be -4. But you can think of it in terms of another number, any other number that you want. When x is 1, y is -4. It doesn't even care what x equals. Okay, so we have that. Notice that we have greater than or equal to, so I'm making a solid line here. Okay, now here's something. I can pick a test point, but please don't lose your good sense. What I mean by don't lose your good sense, we're looking for where all the y values are bigger than -4. Well, the ones where the y's are bigger than -4 are up here. Okay, because that's what greater than means, is -3, -2, -1, 0, 1, 2, 3. All of the y values bigger than -4 are here. Our solid line shows that or equal to. Down here where you've got -5, -6, those are not bigger, so your answer is really just up here. Okay, this one actually is one where it's more awkward to pick a test point than to not pick a test point. But just so you can see it, in case you just love always picking a test point, where is 0, 0? Okay, so my test point of 0, 0. Our original inequality doesn't even have a x value in it, but my y value here is 0. 0 is greater than -4. Yes, that checks out, and yes, that's where it's supposed to be shaded. So that's another method, either by test point or just by sheer good sense. Okay, and good sense is usually, it's always your friend, so use your good sense. All right, let's look at this one. Don't let the decimal point intimidate you. We do take a quick scan of this particular one. It's got greater than, not greater than or equal to, which means I'm going to be doing a dashed line once I start thinking of it as an inequality. And what I would like to do here is I want to think about it being y equals negative x minus 3.5. We are interested in simply getting a graph up there for this, so I want to go by the intercept method. If x equals 0, y equals negative 0. Negative 0 is just 0. We don't call it negative 0. We say the opposite of 0, but it's its own opposite. 0 minus 3.5 gives you negative 3.5. So you start with the ordered pair 0, negative 3.5. 1, 2, 3.5 right down here in the middle. Then 0 for your y-intercept. 0 equals negative x minus 3.5. You need to solve that by adding 3.5 to both sides. So you have negative x equals positive 3.5. And then if you have the hidden 1, sometimes that helps to think about dividing by negative 1. So that means that x equals negative 3.5. So x-intercept 1, 2, 3.5 right here. Okay, now if you think about it in terms of slope, the number that's with the x is a negative, so it makes sense that it would be a negative slope. So when we connect these, make sure, like I say, do not lose your good sense. Okay, you're going to connect these two, but then you need to make sure that you're going down beyond. And you need to make sure that you're going up beyond. We need to put arrows on to show that it's infinite. And we look back here at our original inequality and find that our border is a dashed situation. So I'm going to go through, I'm going to dash this out. Okay, your eraser is going to do much better than my eraser. So I've got a dashed line down here. Y greater than negative x minus 3.5. So what I want to do is I want to do a test point. And some of you, your good sense might be kicking in. And you might be starting to think, wait, I'm starting to see how the greater than works. So if it is good. Okay. But we'll just leave that lie there for now. Y value is 0. 0 is greater than negative 0 minus 3.5. 0 is greater than negative 3.5. That's true. And I'll give you a hint. Most of the ones they gave you on this are true because this is the very beginning steps for you. So 0, 0, my test point right here. Y is greater than negative x minus 3.5. Because there's where the 0 is. So all the points over here where 0 lives, 0, 0 lives, are where all of the answers are living. Okay. All of the ordered pairs over here are not solutions. Okay, so once again, just in case you missed it, there are an infinite number of solutions to these inequalities. Not just one, not just two, not just many. There are an infinite number of them. Whether the borderline is dashed or solid, there are an infinite number of solutions. All right, let's take just one more. Okay, I think you're doing great. Hang in there. We're almost done for the day. As far as your lesson, I hope you took some good notes and paid attention to what was happening here. And I hope that it's getting easier and easier every one I do. All right, so we have or equal to. So we know that we're going to be working this out with a solid line. And I'm taking 2y plus x, and I'm saying equals 12. Let's do this by intercepts. So if I take x equals 0, 2y plus 0 equals 12, and I want to solve this. 2y equals 12, so y equals 6. So I have one of my ordered pairs is 0, 6, 1, 2, 3, 4, 5, 6. But the problem is going to come, I'm purposely not graphing that right now. The problem is going to come, be careful if you have a bigger number here, because when I plug in my 0 here, and I do 2 times 0 plus x equals 12, I get x equals 12. All right, you have a choice, because you're going to have to graph 12, 0. You can either go by ones, 1, 2, 3, and go all the way out to 12. Or what you can do is, instead of going by ones, you can go by twos. It's okay as long as you mark on your graph that you're going by twos. You can go by fours. You can go by whatever number, but every time you pick a gap, it has to be the same gap. So 2, 4, 6, 8, 10. And you have to put in enough of them to establish your pattern. And I want to go this one, 2, 4, 6, 8, 10, 12. Okay, so my first ordered pair is 0, 6. 0, 2, 4, 6. It's right here. Okay, please excuse that. That was a blocked caller. So x is 12, y is 0. 6 and 12 is my x-intercept. 0, 6, 12, 0. So we have this. We're keeping in mind that I'm supposed to be doing a solid line, so you're going to take your ruler or your straight edge and you're going to bring yours down. I'm going to do a good job with mine, so my straight edge goes all the way through like that. Arrowheads to show that I mean that it goes on forever. This is my border line. It's my solid border line. I want to test 0, 0. The only time you can't test 0, 0 is when the line goes through. And I did leave one problem in your homework where 0, 0 is actually where the line passes. And if it does, you have to pick a different test point. So I'll leave that to you to ponder that. That's your challenge for the homework. But for right now, this 0, 0 test point, I'm going to test it. I have x and I have y, so I have 2 times 0 plus 0 less than or equal to 12. So 0 less than or equal to 12, that's true. So since it's true, you go to where the 0, 0 is, and all of the numbers, all of the ordered pairs on that side of the border give you solutions. Okay, so for example, negative 5, 0 is a solution. 0, negative 10 is a solution. 10, negative 2 is a solution. 4, 0 is a solution. All of those numbers will make this true, and all of the numbers on this side will make it false. So the numbers over here are solutions. The numbers over here are not solutions in this case. And so there you have it. There you're done. And I still want you to know that I love you and care about you very much. And I'm believing that we've got some good days ahead. When you turn in your assignment tomorrow, you'll see that I put in a little something that I hope makes you smile. And so let's do our best to help each other to smile and have more good days than bad days, okay? All right, so love you all. God bless you. I'm praying for you, and have a very blessed day.